Welcome to our fifth learning workshop for Chemistry 1406. This will be covering stoichiometry, or the conversion between amounts of one substance and the amounts of another substance. So let's begin. So let's look at, consider this reaction, a reaction of ammonia, which is NH3, with oxygen. When ammonia reacts with oxygen or burns an oxygen, you get nitrogen monoxide, which is the NO, but you also get water. Okay, so many conversion factors exist. You've dealt with like grams to kilograms and things like that. And stoichiometry is using conversion factors, but conversion between different substances. Now, one of the things to kind of keep in mind here is that the ratios given in this balanced equation. This is a molecule to molecule ratio, not a gram to gram ratio. So 4 molecules of NH3 react with 5 molecules of oxygen to form 6 molecules of water and 4 molecules of nitrogen monoxide. However, because a mole is 6.02 times 10 to the 23rd of something, a mole is 6.02 times 10 to the 23rd molecules, the mole ratio and the molecule ratio are the same. So while I say it's going to take 4 molecules of NH3 to form 6 molecules of oxygen, 4 molecules of NH3 to form 6 molecules of oxygen, I could also say it'll take 4 moles of NH3 to form 6 moles of oxygen. And I can convert and I can relate any of these two substances without paying attention to the other two. So 4 NH3 is going to need 5 moles, 4 moles of NH3 is going to need 5 moles of oxygen to react. 6 moles of water will require 4 moles of NH3 to react, etc. So stoichiometry is kind of a big $5 word for the relating of relative quantities of moles using a balanced equation. Molar masses also provide conversion factors that are going to be necessary for us because, as I mentioned before, it's not, 1 mole is not, these are not gram ratios. It's not 4 grams of NH3. It's going to form 6 grams of H2O, and that's because nitrogen weighs less than oxygen. And if I have 1 nitrogen and 3 hydrogens, that's not going to weigh the same. That's not going to be the same amount as 2 oxygens. For example, if I have 4 molecules of NH3 or 4 moles of NH3, that actually turns out to be about 68 grams. 4 molecules, or rather 4 moles of NH3 is about 68 grams. 5 moles of water, by comparison, is about 160 grams. So even though this looks like it's 4 to 5, in terms of grams, it would be like about 68 grams of NH3 is going to require about 150 grams, or 160 grams rather, of oxygen. So as you can see, the 4 to 5 ratio doesn't really work with grams. So that's why we have to use molar masses. Before we convert from moles of one thing to moles of something else, we have to convert moles to grams, or grams to moles usually. So is 4 grams of NH3 to 5 grams of oxygen a conversion factor? No. The equation tells us moles, not grams. Stoichiometry definitely requires you to be precise in your thinking. So let's do a couple practice problems here. This is how many moles of H2O are produced if 0.176 moles of oxygen are used. So if we want to calculate the moles of water, so I'll go ahead and do this one together with you. I'm going to go ahead and change the color of my pen to black. It'll be easier for us to see. Okay, so first thing I have to do is start with what I'm given. Don't know why I did. Oh, what the heck? Don't know why I did that. Let's try that again. So let's see. 0.176. 0.176 moles of O2. So as we've worked on conversion factors before, remember what I always said, follow the units, focus on the units first, and then put the numbers down? What unit is going to have to come down here on the bottom?
0.7.
Well, not 0.7. What unit? I'm not looking for numbers. I'm looking for units.
Mole O2.
Yeah, moles of O2. Exactly, Carla, and right on. Linda, you got it too. So yeah, I'm going to need to put moles of O2 down here. And what am I going to convert to? What am I trying to convert to?
Gram.
In this case, I'm not looking for grams. The question's asking me for H2O, as Frank said. So, but what of H2O? I want to convert. I can only convert moles of oxygen to what of H2O? What type? I can use. Is it grams of H2O? Is it moles of H2O? Is it liters of H2O? What am I converting to? What'd you say?
Mole of H2O.
Moles of H2O. Yeah, and this is a very important point. The only way to go from one substance to a different substance, the only way to change the substance in a conversion factor is to use a mole to mole ratio. So moles of oxygen to moles of water. Now the ratio, the actual numbers, are going to come from the balanced chemical equation. So what numbers do I put on top and bottom?
6.022.
No, I'm not sure where you're getting that. Yeah, Carla said 6 on the top. Yeah, that's right, because the ratio comes from the balanced equation, right? I'm relating O2 to H2O, and so 6 goes on top. What number goes on bottom then? That's right, 5, right? So then I'm going to go ahead and multiply the top and divide by the bottom, and if I do, what do I get? You have your calculators handy? What do I get when I multiply the top and divide by the bottom here?
0.2112.
Exactly. And so in this case, 0.2112. But I only started with how many significant figures?
3.
And so my answer has to be only 3 significant figures as well, right?
Yes.
So this would be what would I call this? What would I write then?
0.211.
0.211. Very good. So I'll just take off this little 2 at the end. 0.211 moles of H2O. Very good. So let's go ahead and take a look at the next one. How many moles of NO are produced in the reaction if 17 moles of H2O are also produced? So once again, we'll go ahead and start with what we're given. What unit goes in the bottom? Unit, not number. What unit goes in the bottom?
Moles of H2O.
Very good, moles of H2O. And what unit goes on top? What do I convert to? Oh, NO. So you're just saying no. Yeah, what of NO? What of NO? grams of NO, liters of NO,
Moles of NO.
moles of NO. Very good. So it's going to be moles of NO on the top. And now I can put my numbers. I don't put numbers until I put my units. Otherwise, I run a very high risk of putting the wrong thing. All right, so what number goes on top?
4.
4. Yep. And what number goes on bottom?
5.
Not
No, 6.
5. 6, yeah. There's a 6-to-4 ratio in the balanced equation. When converting from one substance to another, I use the coefficients from the balanced equation. And then all I have to do is multiply 17 times 4 divided by 6. And what does that give me?
11.3.
Yeah, 11.333, except that this is only 2 sig figs to start. So I'm only going to end with 2 sig figs, so this will just be 11 moles of NO. Very good. All right, now let me have you guys try one. All right. What? Oh, no. So converting grams to moles and moles to grams. Okay, so when we convert grams to moles, we actually, the only way to go from one substance to a different substance is a mole to mole ratio, okay? That's very, very important. The only way you can change the substance, the only way you can change the compound is with a mole to mole ratio. And that conversion factor here, that conversion factor is the coefficients, the numbers are the coefficients from the balanced equation. So, but if I want to convert from the grams of one substance to moles so that I can convert moles to something else, I have to use the molar mass. So grams to moles, I use the molar mass. Moles to moles, I use the mole ratio from the balanced equation. And then if I want to go back to grams, I use the molar mass of the substance again. So if you need to take some time to go ahead and write that out, that could definitely be helpful to you. And note here, you can actually start anywhere along this path. So like for example, maybe you're only going from say, I don't know, grams of something. So you're only going from grams of X to moles of something else, moles of Y. Well, in that case, you only have to do 2 conversions. Convert the grams to moles using the molar mass, and then convert the moles of X to moles of Y using the mole ratio from the balanced equation. Or, let's say instead you are starting with moles of one thing and you're trying to get to grams of something else. Well, if that's the case, you can simply convert grams to moles using the mole ratio. Convert moles of X to moles of Y using the mole ratio. And then convert moles of Y to grams of Y using the molar mass. So you can start anywhere along here. You don't necessarily have to use the whole thing, but you can go backwards and forwards on it. All right, cool. Y'all ready to go? Ready to try some? All right, sounds good. All right, let's do it. And for the above reaction, what is the path that we would take for the following? So given 2 moles of water, calculate grams of water. So for this one, we start with 2 moles of water. For our first conversion factor, what would go on the bottom?
Moles of water.
Mm-hmm. And what would we put on top?
Gram.
Grams
Gram
of
of water.
water. And for this particular problem, we don't even need to use the balanced equation because we're just trying to convert from grams of water to moles of water. Okay, cool. So, how many grams of water are equal to a mole? How can I find that out?
Do you have to find the molar mass of water?
Absolutely, that's exactly what you do. So if I'm looking at water, I'm going to put the calculation up here in the upper right hand corner. If I'm looking at water, I have two hydrogens, right? And each hydrogen has a mass on the periodic table of 1.01. That gives me 2.02. I also have oxygen, there's one oxygen. And each oxygen has a mass on the periodic table of 16, so 1 times 16 is 16. And now I'll go ahead and add them up, and that'll get 18, whoops, 18.02. I don't know what that big line is for. That's 18.02 grams per 1 mole. 18.02 grams per mole. So, 18.02 grams per 1 mole. And then all I have to do is multiply everything on top, divide by the bottom. Technically speaking, with this only being one significant figure, even though this is 36, I'd end up having to make it write it just as 40 grams of H2O. So yeah, there you go. Does that make sense? Let's try the next one. 36 grams of hydrogen. Moles of O2 required for 30 to react with 36 grams of hydrogen. So I'll start with my 36 grams of hydrogen. And I'll go ahead and set up my first conversion factor. What unit is going to go on the bottom here?
Grams of hydrogen?
Uh-huh. And what can I convert grams of hydrogen to? One answer. Yeah, moles. As Frank said, what's this moles? I can convert grams of hydrogen to moles of hydrogen. I can convert grams to moles of the same thing. There you go. And how would I get the numbers, or what numbers would I use? Where would I find those numbers if I want to convert from grams to moles? Where would I get that?
Periodic table.
Yeah, periodic table. So 2 hydrogens is 2.02. 2.02 grams per 1 mole. Molar mass is always the mass of 1 mole. But I'm not done yet because I have moles of hydrogen, but what I really want is moles of oxygen. The only way to get from one substance to another is a mole to mole ratio. So what unit goes on the bottom of the next conversion factor?
The gram H2.
Well, not the grams of H2, because if
No,
I put the grams of H2 on the
no.
bottom, one, grams of H2 is already canceled out, right?
Yeah.
So if I put grams on the bottom, that's just going to introduce a new thing that I have
O2.
to cancel.
O2.
I'm sorry?
O2.
Well, if I put
Oxygen.
O2 on the bottom, is that gonna cancel out the H2?
No, it's
Moles of
Yes.
O2?
Well, not. Oh, once again, even if I do put moles of O2, moles of O2 is what I'm trying to find, right? So I need the unit that I'm trying to find. I need that on the top. If I have moles of O2 on the bottom, that doesn't cancel with the moles of H2 previously on top. So I run into a problem there, right? what unit has to go on the bottom? Remember one of
Moles
our
of hydrogen?
moles of hydrogen. Yeah, remember what our previous, whenever we did conversion factors previously, we always looked at it like this. We always said whatever is up here has to come down here so it cancels. Okay. Now that moles of hydrogen is up here, that has to come down here so that it can cancel. And I keep doing that until I get to the unit that I want. Okay. So what can I convert moles of hydrogen to then?
Moles of oxygen?
Uh-huh. I can convert moles of hydrogen to moles of oxygen. With a mole to mole ratio, I can change the substance. So how many moles of hydrogen is going to react with how many moles of oxygen? What's the ratio there?
Oxygen is 16, right?
Sorry, Linda, I didn't quite hear you.
I said oxygen is 16.
The mass of one oxygen is 16. But here's the thing. When I'm doing a mole to mole ratio, where do I get those numbers from?
From the
When I
periodic
do a
table.
mole to mole
So
ratio, where do I get those numbers from?
it's one oxygen and two hydrogen?
Yeah, the mole to mole ratio has to come from the balanced equation. So yeah, that's one oxygen to two hydrogen. Does that make sense? Any questions on that? I'm using the coefficients here for the balanced chemical equation. And obviously there's no number in front of oxygen, which means there's an assumed 1. All right, cool. So now I'll go ahead and multiply everything on top and divide by the bottom. And what do I get? Not 18, I think somebody said 18. Remember, I have to divide by everything on the bottom. So 36 divided by 2.02 divided by 2. That's right, 8.9. Very good. Round to the appropriate number of sig figs should be about 8.9. 8.9 moles of O2. Admittedly, I thought it was going to be something else. 8.91, yeah. No, it's 8.9. Yep, very good. Very good. Thought it might have been 9.0, but it was an 8.9. Very good. Now to the grams of H2 produced from 6 grams of O2. So this is going to be, if I want to get from H2O to O2, remember the only way to get from one substance to a different substance is with a mole to mole ratio. Mole to mole ratio. Since I'm starting with grams of O2, I'm starting with grams of O2 and I'm trying to get to grams of H2O, I can see basically I'm starting with the grams of X and trying to go all the way to grams of Y. So I'm going to have to do a molar mass conversion to get the moles, a mole to mole conversion to get to the other substance, and then a moles to gram conversion to get back to mass. There's going to be 3 conversions here that I'm going to need. So if I'm starting with 6 grams of O2, what unit goes on the bottom?
Grams of O2?
Very good. Ooh, my little marker, it doesn't like me. It always wants to make these ridiculously long lines. I'll change it. There we go. Grams of O2. And what can I convert grams of O2 to? What goes on the top? What unit?
Is it moles of H2O?
H2O.
Oh, I can't convert.
Grams of H2O.
No, the only way I can change the substance is with a mole to mole ratio. Remember that. The only way to change what the compound is to do a mole to mole ratio. If I want to go,
Oh,
if I'm
1 mole.
converting from grams, I can only go to moles of what? From grams, I can only go to moles of what?
Of O2.
Of O2. So I'm starting with grams, I can only really go to moles of the same thing. And that's what this is showing. If I'm starting with grams of X, I can only go to moles of the same thing. So oxygen 16, 16 times 2 is 32. So 32 grams is equal to 1 mole of O2. Very good. Now, next conversion factor, what unit goes on the bottom now?
1 mole O2.
What do you think?
Mole. No. Gram O2.
Well, grams of O2 is already canceled out.
No, did you say what goes on the bottom or the top?
I'm looking for what goes on the bottom. What goes down here?
The mole O2 now. Mole O2.
Moles of O2, exactly. Whatever was previously on top goes on the bottom now. And what goes on the top of this conversion factor?
Over the
What
grams
can I convert
O2.
moles of
Grams
O2?
H2O.
Oh, I'm
Gram
sorry, what did you say?
H2O. Gram of
Not
water.
grams of H2O, because remember, the only way to go from one substance to another is a mole to mole ratio. I can't go from moles of one
Oh, I
thing to
see.
grams of something else. I can
The
only
mole of
go from
water
moles of
then.
one thing. Yeah,
Mole of
so
water.
there has to be moles of H2O. Yep. So since it's a mole to mole ratio, that means I'm going to have to use my balanced equation. So what numbers go on top and bottom here?
2 H2O and 1 O2.
Very good, exactly. And now I'm going to go ahead and do one more. Go to the next one. What unit goes in the bottom of this last conversion factor?
6.
Not number, unit. What unit?
Mole H2O.
Moles of H2O. And what can I convert moles of H2O into? What am I trying to convert to?
Grams of H2O.
Grams of H2O. That's what I'm trying to reach. And see, now that I see it's a moles to gram conversion, what number am I going to put on top and bottom?
.02 at the top and 1 at the bottom.
What is one? It is 1 mole. Molar mass is always equal to 1 mole. This is H2O. This is not H2. What's the molar mass of water? What's the molar mass of H2O? Yep, 18.02. Right on, Frank. So, trying to find my little cursor. Here we go. Yeah, it's 18.02 because we have to take into account the mass of the oxygen as well. 18.02 grams of water is equal to 1 mole of water. If you're struggling a little bit with the stoichiometry stuff, don't feel too bad. Everybody struggles with this at first. It's not the easiest thing to get, but with practice, you will definitely get it. So moles of O2 cancels out, moles of H2O cancels out. And Linda, note, the reason why I emphasize put the units first before you put your numbers, you automatically assumed down here it would be a 6. And I'm not sure why, but if you don't know what the numbers are, or rather, if you don't know what units you're converting, it's very easy to make a mistake. Maybe if you look up at the equation up here, you see, oh, there's 2 H2O, so maybe I'll just put a 2 in front of moles of H2O. But that wouldn't be correct, because the only time you use the balanced equation numbers is when you're doing a mole to mole conversion. When you're doing a gram to mole conversion, it's always the molar mass is equal to 1 mole. So let's go ahead and calculate that and see what we get. And just as a reference, what I usually like to do when I'm calculating something like this is I multiply everything on top and divide by everything on bottom. I don't actually put any parentheses anywhere, so I'll just say 6 times 2 times 18.02 divided by 32. I ignore the ones because anything times 1 is itself. And in this case, since it started with only one significant figure, my answer, though it's 6.7575, I'm going to end up rounding it to just 7 grams of H2O. So yeah, right on, Frank. You got it. All right, cool. Any questions on that? Does that make sense?
Please, Michael,
Yes?
can you explain this part? 2 moles of water, and here I see the mass. As a bit here, these two places.
Oh, what are you talking about now? Sorry.
Here I know 2 moles of water, right? Over one time, this mass, this is the mass. Okay. But can you explain to me clearly, please? Why do you take this?
Why do I use 1 mole of water is 18.02 grams?
2 moles of water and the mass. Why? Can you explain to me, please?
Are you talking about up here? I guess I'm not entirely sure of your question. Because I don't actually have 2 moles of water is equal to any particular. Oh, are you talking about question number 1?
Question number 3.
Question number 3.
Yeah, where do you take this 2? This figure 2.
Where do I get this to? The one right here? 2 moles of water to 1 mole of oxygen. Okay, that ratio comes from the balanced equation. That comes from up here. Okay. Whenever you're converting moles to moles, you do so with the balanced equation. So there's a 1, an implied 1 in front of the oxygen. So 2 moles of water is going to require 1 mole of oxygen. Whenever I'm using a mole to mole conversion, I look at the coefficients in the balanced equation. Does that make sense?
Okay.
Don't worry, we'll definitely do more practice with this.
Thank you.
Okay. For example, let's take a look at this one. Stoichiometry questions. So consider this equation that we used in the first. So this is that same equation that we used in the first, when I first introduced the idea of stoichiometry to you. Ammonia reacting with oxygen to form water and nitrogen monoxide. So it says how many grams of water are produced with if 1.9 moles of NH3 are combined with excess oxygen. So when it says excess oxygen, just means that there's more than enough oxygen to react with all of the 1.9 moles of NH3. So there's more than enough oxygen to react with all the 1.9 moles of NH3. So you're going to want to convert the moles of NH3 to grams of water. Go ahead and try that. I want you to have some practice trying this on your own. Take a minute or two, based on what we've already done together, and let's have you practice this on your own, okay? I'm going to give you all a couple minutes to do this. We'll just do the first one for now. Once you have the answer, or once you have an answer you think might be right, or if you give up, go ahead and raise your hand. So try that first problem. Once you have an answer, or if you give up, If you don't feel like you can get the right answer, if you don't know what to do, just go ahead and raise your hand. Either way. All right, Carla's got an answer. Good. We'll just give a few, just another minute, see if anybody else can come up with something. How about you, Frank? You got this one? Okay, Von's still thinking. All right, tell you what, let's go ahead and take a stab at it, and then we'll let you try again on the next one. All right, let's work on this. We'll work this one out together. All right, Carla, did you have an answer? Or do you feel like you
I
know what to
got
do?
I got 51.
Okay, I actually think that is correct. So what did you start with?
I started with our given, which was 1.9 moles of NH3.
Excellent, excellent. And then for the first conversion factor, what did you do?
I did mole to mole.
Okay, so moles on the bottom of NH3,
Yes.
and then
And
what went on top?
mole of H2O.
Very good. And what was the number ratio?
6 mole of H2O and 4 mole of NH3.
Awesome. Perfect. Now, what did you do next?
Then I brought my unit that I wanted to cancel out, which was mole of H2O, brought it down.
Okay.
And the unit that I wanted to find out, which was grams of O2.
Mm-hmm.
And I had to find the molar mass.
What was it, grams of O2 or grams of H2O?
Grams of H2O.
Okay. All right, let's take that out. I'll go ahead and fix that. Yeah, I thought that what you meant. I thought that was what you meant. All right, and then how many grams per mole?
I used my teacher's periodic table, so the gram that I got for H2O was 18.015.
Ah, the accurate one. Okay, cool. So then you just multiply everything on top and divide by the bottom, and that gives you
51.34275, but there's two sig figs, so 51.
absolutely 51 grams of H2O. Awesome. And that is 100% correct. Very good. You
Yay.
nailed that. You're a champion at stoichiometry.
I just need to learn how to balance the equations. I have to go look back at your video, other video for balancing
Oh yeah,
that
balancing
one.
can be a little tricky.
Yes.
So how about that? Did everybody understand? Yeah, did y'all understand how that worked? Any questions on that? Frank, Linda, Eva, what do you think?
Bro, I'm not just. I'm floating.
So do you feel like you got an idea of how it's starting to work?
Yeah, I think if I apply myself, I'll get it. It's just that I think right now my head is not thinking. So
Yeah.
yeah.
Yeah, the excess oxygen is not particularly relevant. It's just, see, here's the thing, and we're going to deal with limiting reagents in just a second, but the limiting reagent determines how much can be produced. So the limiting reagent limits or determines how much can be produced. So by saying excess oxygen, that means your NH3 is automatically your limiting reagent. So when I ask you how many grams of H2O are produced, you're going to use your limiting reagent to find that out. So it's not completely irrelevant, but as far as you're concerned at this point, yeah, it's not anything you need to worry about. All right, let's go ahead and take a stab at the next problem. It says how many grams of oxygen are required to produce 0.3 moles of water with this equation? So go ahead and take a stab. Since it's a similar problem to the one that you just did, go ahead and take a stab at it. And let's see what you get. Once again, raise your hand once you've got an answer. Okay? All right, let's go over it. Let's take a look. We'll see what we get. All right. So you start with your 0.3 moles of H2O. And so Frank, what goes on the bottom here? Yep. 1 mole of H2O, yep. You're going to convert moles of H2O to what? What goes on the top? Ah, well, that's not quite right. Now, you could convert moles of H2O to grams of H2O, but that's actually going to put you farther away from your goal. So your goal is that you're trying to get to grams of O2, and the only way to change the substance, the only way to get from moles of water to, the only way to change from water to oxygen is a mole-to-mole ratio. So this,
Is
unfortunately,
the answer 4.5?
is the answer what?
Is it 4.5?
Actually, I don't know. I don't remember. I'll have to find out.
Okay.
All right, what goes on top? What's the unit that goes on top? Maybe you can help me with that, Linda.
Molar 2.
Moles of O2. And what's the ratio? What numbers on top and bottom?
I think 5.
5. Okay. And on bottom?
I think 6.
Yep, 5 to 6. Very good. And then what goes in the bottom of the next conversion factor?
1 mole O2.
Uh-huh. And then what goes on the top?
18.02 gram H2O.
Okay, so I'm trying to find the grams of oxygen, right?
Oh, oxygen. What? Oxygen is 16. Is oxygen not 16? 16.
Well, there's 2 oxygens though, right?
That's times 2. That's 32.
32.
Yeah, exactly. So this is 32 grams of oxygen is equal to 1 mole of oxygen. And now I can multiply everything on top and divide by everything on bottom. And if I do that, what do I get?
8.
Very good. You get 8 grams. 8 grams of oxygen. Carla, is that what you got?
Yes.
Awesome. Does that make sense? Does that help?
Yeah.
Okay. Let's go ahead and tackle another one.
Another one? Oh, Lord.
Yep. Says how many grams of NO is produced if 12 grams of oxygen is combined with excess ammonia?
How many grams of
We'll start with our 12 grams of oxygen. What do we do from here? Go ahead, and I'm gonna once again I'm gonna give you guys a chance to tackle this on your own because I really want to give you an opportunity for independent practice here to see if you can work this out on your own because that'll really help you. And we'll go over it together. Go ahead and raise your hand once you feel like you have an answer. Or you can also raise your hand if you give up. Good job, Carla. You are fast at this. How are the rest of y'all coming along? Pretty close.
Is it 57.6? Is that the answer? Like,
Well, you want me to give it away?
yes.
No.
Are we supposed to use the equivalent of NO on the periodic table?
Yeah, you're gonna use the well. You'll have to get the more massive NO. That is correct. Using the periodic table.
So that would be like 1728.
Mm, no, no. The more massive nitrogen monoxide is just nitrogen plus oxygen.
30.
14 plus 16.
Yes,
That's gonna
30.
be that's gonna be
Yeah.
30.01.
Is the answer 1728?
Mm-mm. No,
No.
unfortunately.
Chai. What did I do wrong now?
It could be just the way you're putting in the calculator. Looks like
Let me
Frank's
see.
ready to go. Let's go ahead and see what we got. All right. So,
432.
do you have any volunteers who want to guide us on how to proceed?
Lord. I'll
All
try.
right. All right. What goes on the bottom of the first conversion factor?
5 mol O2.
Well, this is grams of O2 that I'm starting with. So, what goes on the bottom?
Gram O2.
Grams of O2. And what goes on top?
Mol O2. No, gram H2O.
Oh, no, you can't go from one substance to another unless it's a mole to mole ratio.
Mol O2. Mol
Mole.
H2O.
Well, no, I can only go from one substance to another with the mole to mole ratio. So,
I give up.
in this case, yeah, remember, whenever I have grams, I have to go to moles of the same thing, moles of
Oh, I
O2.
see. Okay.
Okay? And if that's the case, it's going to be 1 mole is equal to the molar mass, right? And what's the molar mass of O2?
16 times 2. That's 32.
Uh-huh. 1 mole is equal to 32 grams. All right. What goes in the bottom of the next conversion factor?
1 mol O2.
Mm-hmm. And what goes on the top?
6 mol H2O.
Nope. Now the unit moles of O2 does have to come in the bottom. But keep in mind, what are we trying to solve for here?
NO.
Grams of NO. So the only way to go from one substance to another is what type of ratio? Yeah. And Frank got it. It's a mole ratio, so we're going to have to put moles of NO on the top. Very good, Frank. Thank you. Now, as far as the numbers, what are the numbers going to be?
Mol NO will be the 4.
So what do I look for the ratio? Frank says it's a 4 to 5 ratio. Where'd you get those numbers, Frank?
I would think it's 30 for NO.
No, no, you have to remember when we do a
4,
mole,
4 NO. 4 mol
yeah,
NO.
4 moles of NO, exactly. When we do
Mm-hmm.
the mole to mole ratio, it has to come from the balanced equation. So you got the 4 moles of NO
Mm-hmm.
to the 5 moles of H2O.
Mm-hmm.
So it is a 4 to 5 ratio. Now I have moles of NO, I have to go to grams of NO.
Mm-hmm.
So what unit is going to go on the bottom of this next conversion factor?
1 mol NO.
Yep, 1 mole of NO. And what's going to go on the top? What am I going to convert that to?
30 gram NO.
Yeah, grams of NO. So 1 mole of NO is equal to the molar mass, which is 30.01 grams of NO. And then all I have to do, I can check and make sure that my units are canceling properly. I have grams of O2 canceling with grams of O2. Moles of O2 cancels with moles of O2. Moles of NO cancels with moles of NO. And I'm left with grams of NO, and that's exactly what I want. So I multiply everything on top and divide by the bottom, and what do I get?
Nine.
Exactly. 9.0 to be precise, because there's two sig figs to start, so 9.0 grams of NO. Cool? Very good, Carla. Yeah, and sometimes people just, uh, sometimes you just need more practice before it clicks, and sometimes people get it right away. But usually it's a little bit of a struggle. The stoichiometry stuff is usually a little bit of a struggle for students. But if you keep in mind that guide I showed you, um, I can also actually draw a little diagram. Um, this is a diagram that I usually like to show students because I think it sometimes helps. So I have to start with moles of a substance. Okay, we'll just say moles of A. Okay, if I have moles of A, I can do a lot of different things. I can convert to grams, but if I can only convert to grams of the same thing, A. I can convert to atoms or molecules. And to convert from moles to grams, you need the molar mass. To convert from moles to atoms or molecules, I use what? Does anybody remember? What do you use to convert from moles to atoms or molecules?
6.022.
Yeah, Avogadro's number, right? The Avogadro's number. So 6.02 times 10 to the 23rd. And to convert from moles to grams, I just need the molar mass, right? So the molar mass is what I need here. Now, the other cool thing that I can do with moles of something is I can use moles to convert to moles of something else. Moles of B. But to do that, I need a balanced equation. And if I have moles of B, I can actually use that to convert to grams of B. And admittedly, in the not too distant future, you're also going to learn about the fact that you can convert moles to the liters of solution. Because you're going to have a chapter on solutions coming up very soon. Right after the gases, you're going to start talking about solutions. And this is going to be one of the new conversions you're going to end up learning. So this is kind of like a conversion map to show you all the different things that you can do with moles. So to convert, we already know some of these, to convert from moles of A to moles of B, I just need a balanced equation. And to convert moles of B back to grams, I just need to use the molar mass. Notice that there's no way to go from directly. There's no direct path between here and here. There's no way to get from grams of B to grams of A. I can't do that. That doesn't work. There's no path to follow. I can't go from grams of one thing to moles of something else directly. There's no path between those two. The only way to get from one substance to a different substance is through that mole-to-mole conversion. And soon you'll also recognize that to go from moles to liters, you can use the concentration of molarity. But you'll find that out soon enough. This is kind of like a conversion map to guide you on as to what you would need to do to convert from one thing to another. You're starting with grams. In this case, I'm starting with grams of NO. So I'm starting here. And I need to get to grams of something else. So I need to go here. First thing I have to do is convert the grams of O2 to moles of O2 using the molar mass. Once I have the moles of O2, I can then, once I have the moles of O2 here, I can go to moles of something else by going from moles of A to moles of B using the balanced equation. Moles of A to moles of B. Once I have moles of B, I can convert back to grams using the molar mass. I can convert moles of B to grams of B using the molar mass. Does that make sense? Now I don't know if that map helps. I hope it helps. I hope it doesn't make it more confusing. Oh, good. Thank you, Frank. I'm glad. Um, but yeah, that's kind of like you have a number of different options here. So you have to know what you can convert and what you cannot convert. And so that's why I always say follow the units first. If you let your units guide your thinking, you'll be able to better determine what you have to do. Once you know what units you're converting from and to, then you can figure out what numbers you're going to need. Okay, cool. So let's take a look. Now, just out of curiosity, are you all covering limiting reagents? Does anybody know if you're covering limiting reagents in your class? Sometimes the professors do, sometimes they don't with 1406. Okay, well, just in case they do, let's go ahead and take a look at some limiting reagent stuff. And there's just some extra problems in here. Actually, you know what? I don't think you're going to be covering limiting reagents. So why don't we take a stab at doing some of these extra problems here? How many moles of water can be made using 0.5 moles of NH3? How many moles of water can be made using 0.5 moles of NH3? So let's go ahead and have you practice with some of these, because I think that's going to be more helpful to you than talking about limiting reagents, which you're probably not going to be required to cover during your class. So we'll practice on these three. We'll go over them together, and then I think we'll call it a day. Let's take a shot at A, and I guess it's A and C, A, B, and C. So it's supposed to be. Yeah, go ahead and take a shot at these. Once you have A done, go ahead and raise your hand, and we'll go over it together. Okay, so how many of you got the first one right? You got it? Did you get 0.8 moles of water? Awesome, awesome. Well done. Has anybody finished the second one? Not yet, huh? Yep, mass is grams. So, yeah, it wants to know the grams of NH3.
Is it 25.5?
Are you talking about the second A one?
The second one, is it 25.5?
Is it 25? It is, yes, it is. It's 25.6, or which you would round to
That's
26.
26. You're round to
Yeah,
26. Yeah.
well done. So I'll go ahead and show how you would work it out, and you can let me know if you did it, like if you set it up properly.
Okay, 1.5 mole of NO times, at the bottom you have 4 moles of NO, and at the top you have 4 moles NH3. 4
Very good.
times 1 mole NH3 at the bottom, NH3, 1 mole.
Uh-huh.
Then you have 17.03 gram NH3.
Okay.
NH3, which is equal to 25.5 and
Uh-huh.
approximated to be 26.
26 grams.
Yeah, 26, which is 2 sig fig.
Excellent, excellent. Well done, Linda.
That was a miracle.
There you go. There you go. No, that's awesome. You're picking it up now. That's awesome. All right, let's try. Let's see if we can nail down number or letter C. And Carla and Frank, how'd you guys do? Did you get the second letter A? Excellent, excellent. Well done. Last chance at redemption, my friends. Let's take this down.
I don't think my answer is correct. I doubt it.
You got an answer, but you don't think it's correct?
Yeah, I don't think it's correct.
Why? What would you get for your answer?
I got 211.3. I don't think so.
That's right.
Yeah?
Yeah, that's right.
It's not correct, right?
No, it is correct.
It's correct?
Yeah, no, you got it correct.
211.3?
Yeah, that's correct.
Okay, that's good.
Now, the only thing is that with sig figs, it would. I mean, technically speaking, it's only two sig figs, so it'd be 210.
Okay, yeah. So to
But
be 21.
yeah,
Oh, okay.
but good job. So let's go ahead and take a look at this. And look, and dang, it's like you're finishing pretty fast now too.
Yeah, that's 120
Yeah,
NH3
so
times
you're gonna
times
start getting. You're gonna be faster than Carla before you know it.
17.03 gram NH3.
Yeah, 17.03 grams NH3 on the bottom.
And the top has 30 gram NO, I mean to say.
Well, actually, it's supposed to be 1 mole NH3.
Okay, okay. Of NO. Mm-hmm.
So you might have gotten the right answer, but not set it up properly.
Yeah, I think
That's
so.
possible. So after 1 mole, if you convert the grams to moles, now that you have moles of NH3, now you can convert moles of NH3 to moles of the NO.
Okay.
Whoops, I messed that up. My bad. Let me fix that. There we go. Oh, come. Oh, there it is. Okay. Ooh, don't like that. Fancy. Don't like it. All right.
30 gram NO. Okay.
The only way times to use the molar mass is when you're doing a gram to mole conversion. In this case, the mole to mole is just going to be the 4 to 4.
I don't know how to do this. I think that's the challenge I'm having. Setting up this whole thing is just.
Yeah, you have to make sure that whenever you're changing the substance, whenever you're changing the compound, if the compound changes from one thing to another, it only happens in a mole to mole ratio.
No, you
Otherwise,
did it. You did it wrong because this N it's supposed to be NH3 at the bottom, then NO at the
oh
top.
yes, okay, you're absolutely right. So I wasn't paying close enough attention to that, my bad. So let me fix that.
Times 1 mole NO over 30
NH3, NO,
Yeah, I got that now.
and then you can convert the moles of NO back to grams.
Yeah, NO 1 mole NO over 30
Yeah,
30 gram NO. Yeah,
yeah.
30.
30.01 grams of NO is equal to 1 mole of NO. And then I just multiply everything on top and divide by everything on bottom.
It's 211.
Yep.
0.3, which is 21.
Well, technically, I guess it would just be 210 because the initial number here, or the 120, really only has two significant figures. So this would actually be over here. This would actually be 210
Yeah,
grams of NO with the appropriate sig figs. I'm going to do this. Right. How about you, Carla? Frank, how'd you guys do? Did you get that one? 210 for Carla? Very good. How about you, Frank? Oh, okay. You thought you had it wrong, but you actually had it right. Oh yeah, no. And sometimes sometimes the numbers can surprise you, but no, it looks like you're good. Excellent. Well, I'm really glad y'all were able to see. It seems like everybody was getting them correct at the end, so that's really good. I definitely recommend more practice with this because this is kind of a trickier concept. Um, Let me show you where you can find some more of that practice. Turns out if you go to our beautiful website, you're all familiar with, the SE Science Learning Center, the TCC SE Science Learning Center, Chemistry Web Resources, and scroll down to Chemistry 1406 under Practice Problems. There's under Chemical Reactions and Quantities, after the balancing equation stuff, there is mole ratios and mole conversions, moles to gram conversion problems, grams to gram conversion problems, mixed stoichiometry 1 and 2. I'd recommend these two especially because these two involve, well, especially mixed stoichiometry 2, this involves balancing equations and predicting the products. So you have to balance the equations, or not predicting the products, but balance the equations and then doing the conversions. And in some cases, you have to actually write the equations out. It doesn't actually give you the formulas. So this will be good practice for you to kind of catch up, go back and look over that balancing equation stuff and do that as well as practicing your conversions. Or if you just want to practice some simpler conversions, you can just do mixed stoichiometry 1. And this will have some good examples of all the different types of conversions that we did here. It's just a few problems. You could skip this first part up here, 1 to 4, which is just writing the conversion factors. But problems 5 through 10 will give you a good sampling of different types of conversion problems. And as always, all the answer keys are complete, they're worked out. You can see all the work and see if you're doing it right, etc. There's also limiting reagents here, which might be a good practice for you as well. And then, of course, the mass-to-mass conversion problems. There's lots of good ones there as well. So, lots of good practice for you if you wish. And you can also feel free to check out some of the practice tests if you're interested. Thank you for coming to our workshop. Have a great day. We will see you next week.